Okay, guys, so we're picking back up in the middle of page 6. So we just solved for how many grams it would take of calcium chloride to make a 500 milliliter 6 molar solution. So our objective now is to describe the preparation and properties of solutions. So for number 6, we're going to describe the steps to make the solution above in number 5. So we already did the hard part. Number 1, you have to figure out grams. You have to solve for grams. So if you go to lab, you have to first have the number that you need, so solve for grams. Then we're going to actually measure out that number of grams. And when you're thinking about this, realistically, this should have been 500.0 milliliters. So we would want to have that 332.94. We wouldn't want to round and say roughly 300 grams. That would not be a very precise answer. So you're going to measure out the grams. You're going to add it to your glass, to your glassware. So it's going to be a special type of flask we'll see in lab. Then you're going to add your water, and you want to have about 500. I'd recommend you add about half the water, stir it, and then add the rest of the water, and then you're done. Okay, so next thing we're going to talk about is dilutions. I want you to look really carefully at beakers number 1 and beaker number 2. They each have 1, 2, 3, 4, 5, 6, 7 particles. 1, 2, 3, 4, 5, 6, 7 particles. So we could say that is, maybe 7 moles. Comparing them, beaker number 1 is very concentrated. Even though the number of moles are the same, number 1 and number 2, beaker 1 has a very high molarity, a very high concentration, because it also has a low volume. Beaker number 2 is pretty dilute by comparison. It has the same number of moles, but it has a low molarity because it has a high volume. So number 1 and number 2, we have the same number of moles. That's N1 equals N2. So a number of moles are equal, but the concentrations and the volumes are different. So because we know that moles before and after are equal, if we want to take solution 1 and dilute it to make solution 2, we could do some simple math. So here's our equation. Molarity 1 times volume 1 will equal molarity 2 times volume 2. We can use that N being constant to set these up in relationship to each other. Remember, our original equation is M equals N over liters. I'm just going to switch out that liter part. So instead of liters, we could say volume at the bottom, couldn't we? So really, molarity times volume equals my number of moles. And if I have two setups, if I have M1, V1, N1, and I have M2, V2 equals N2, if N1 and N2 are equal, that means M1, V1 equals M2, V2. So if you wondered, that's your algebraic proof for you right there. So let's flip the page and do some of those problems. So with some of these examples, I'm going to want you to pause, go through, try the problems on your own, and then check back with the work. I'll talk you through the whole first one. So we're asked to find how many milliliters of an aqueous 2 molar magnesium sulfate solution must be diluted with water to prepare 100 milliliters of aqueous 0.4 molar magnesium sulfate. So here's my concentrated one, and then this is my diluted one. So we're going to start with our equation, and we want to figure out how many we need. We're actually searching for, let's see, what are we looking for? How many milliliters of that do we need? So we've got M1 V1 equals M2 V2. This is going to be my molarity 1. This is going to be my molarity 2. This is my V2. And then this is my V1. So M1 is 2.00 times V1. We're looking for that. M2 is 0.400 times V2. Now we want to make sure we keep this in liters technically. Here it would cancel itself out because we're actually solving for milliliters, but let's just kind of practice some good scientific accuracy. So 100 milliliters, that's 1, 2, 3, that's 0.1 liters, so 0.1000 liters. So I need to isolate and solve for V1, so I'm going to divide each side by 2. So V1, I want you to pause, plug this into your calculator, and give me your answer. Okay, so let's look at your work. So you should have gotten 0.2 liters, and when you convert that back to milliliters, because that's what you were asked for, it would be 20 milliliters. So we would need 20 milliliters of that 2 molar solution to dilute it into 100 milliliters of 4.4 molar. So we have to add 80 more milliliters to it to get that desired concentration. Let's look at number 3. So we're asked how many milliliters of a 4 molar potassium iodide are needed to prepare 250 milliliters of 0.76 molar potassium iodide. So this is going to be my V2. This is going to be my M2. Here is concentration 1. Here is volume 1. So I'm searching for volume 1. So if we start with M1V1 equals M2V2, and let's plug in what we know. So we know that we have a 4.00 molar times V1 is equal to a 0.760 molar times 250 milliliters. You really could plug in 250. I'll show you. It'll work since I'm asked for milliliters out. But just keep in mind, you're doing that with milliliters, not with liters. Technically, you should convert that into liters. Okay, so I want you to isolate and solve for V. So we're going to divide each side by 4. So you're going to get V1 is equal to 47.5. So make sure you pause this video and take a second and make sure that you got that same. Okay, and let's look at number 4 together. So what is the final concentration of a solution if 75 milliliters of a 3.5 molar solution of glucose is diluted to 400 milliliters? So I'm starting with this. This is my V1. This is M1. It's diluted to 400 milliliters. So 400 milliliters, that's my V2. And they're asking final concentration. So I'm trying to solve for M2. So start with your equation. M1 V1 is equal to M2 V2. M1 we saw was 3.5 molar. V1 is 75 milliliters. So just make sure that if we're using milliliters here, we have to get milliliters on the other side. And we don't know M2, but we do know that V2 is 400 milliliters. So I want you to pause, isolate, and solve for M2. Okay, so with your work, you should have got the concentration was 0.65625 molar. But how many sig figs do we want? Here there's 3, here there's 3, here there's only 1. We'll just make that, actually all this should really be to 3 sig figs. So if we want to round that, that should be 0.656 molar. Remember that molar means moles per liter. And number 5, how could you prepare 500 milliliters, here we do have those 3 sig figs, of a 0.2 molar sodium chloride solution using only a solution of 1 molar sodium chloride and water? So this is my second volume, what I'm ending up with. This is my second molarity concentration. So using only 1 molar sodium chloride. So this is my concentration 1, and they want to know how much water did I need. Hold on, let's see. Let's work this out. This one's a little bit funny. So you want to prepare 500 milliliters of 0.2 molar using only 1 molar sodium chloride and water. So how much volume am I starting with? So let's talk through that problem. So M1 V1 equals M2 V2. First molarity is 1.0 moles per liter times V1. I want to end up with a 0.20 molar solution, and I want to have 500.0 milliliters of it. So I'm going to divide everything by 1 to get V1. So V1 is 0.2 times 500 divided by 1. So you should get 0.10 milliliters. So what this is saying is I need 0.1. Oh, is that milliliters or liters? Oh, that's my liter answer. I already converted. So hold on. We're going to go back and fix that. My calculator, I did it in liters, but here I did it in milliliters. So we're taking 0.2 times 500 divided by 1 should be 100. So 100 milliliters, which is 0.1 liters. So if you take 100 milliliters of your 1 molar sodium chloride solution and you dilute it up to 500, that will give you a 0.2 molar solution. So here's kind of a picture that shows some of the things you'll be seeing in lab. You can use a larger pipette to fill up our volumetric flask. Then when you're getting close to the line, you want to start using the more precise wash bottle. and even a dropper to get right up to that line. So in general, there are actually 9 steps to preparing a solution. So here are those 9 steps. Number 1, you need to calculate molarity. So calculate the molarity, the concentration of your solution. Number 2, you need to calculate the volume that you need. Or you have to find it out or read the question or figure out exactly what concentration and what volume do I need. The third step, you have to solve for my number of moles, which remember that is N in these equations. Number 4, you need to solve for my number of grams. And whenever I say grams, you should think periodic table. You need to use your molar mass. So you need to use your molar mass and your factor labeling to get your grams. So once you've done all of that, you actually have to weigh out the mass of your solid. So you got to get the mass of your solid. You put the solid in your volumetric flask. So solid in the flask. And then you're going to fill, so I'm going to actually put my little solid in the flask here. Then you want to fill about halfway with water. So we're going to fill it up maybe about halfway. There's my water. And then number 8, you want to shake. So we can get it all dissolved. So I'm going to shake it. Number 9, you want to finish adding the water. So add the rest of your H2O. Now I want to zoom in about what's going on right here. You're going to see this in lab. So here's my zoom in picture. So you're going to see a line on the neck of the volumetric flask that will say, you know, like 500 mils, or maybe it's 250, or maybe it's 1,000. When you are measuring your water, you want to get the very bottom of your meniscus on that line. To do that, you're going to have to use a pipette and add drop by drop at the end when it gets close. So to have the exact right number, the meniscus should be on that line. We're going to practice doing that in lab. Okay, and that is the end of our chapter 12 notes for now. We're going to finish page 8 in class next week.